Welcome to my favorite part of the brain presentation. I'm Melissa Neely-Nicolini, and today I'm going to be talking about the corpus callosum. The corpus callosum is a wide band of axons connecting the right and left cerebral hemispheres. It is composed of millions of nerve fibers that connect the two halves of the brain. These fibers traveling together from one cerebral hemisphere to the other form a brain structure. This image shows a sagittal section of the brain, which is a slice that runs from front to back on a vertical plane. This slice passes through the midline. The large curved structure in the middle of the brain is the corpus callosum. It is the largest of multiple commissural connections between the two sides of the diencephalon and the telencephalon that carries most of the axonal connections from the neocortex to the opposite neocortex. In an adult human, it is approximately 10 centimeters long, 1 centimeter wide, and contains approximately 200 million axonal fibers. Standard anatomic divisions are the rostrum, genu, body, isthmus, and splenium. It is believed that the fibers that pass through the different regions of the corpus callosum represent the anterior to posterior organization of the cerebral cortex. The anterior to posterior organization has been demonstrated by Marie-Christine de Lacoste and colleagues in the human brain. That is, the right and left prefrontal, orbital frontal, and frontal language areas are connected in the rostrum and the genu. That's in this area. The anterior part of the body carries fibers from the sensory and motor regions that abut the central sulcus. That's in this area. It appears that fibers from the area around the sylvian fissure associated with language function in the left hemisphere cross in the posterior part of the body or isthmus. That's in this area. And finally, the splenium carries the fibers connecting the visual areas to the occipital lobe, and that's in this area. Here's a quick video explaining the anatomy of the corpus callosum.
To understand the role of the corpus callosum, it is first important to remember that the brain is divided into two cerebral hemispheres, right and left, separated from one another by a long groove called the medial longitudinal fissure. These two hemispheres are nearly mirror images of one another, but they do not function independently, and communication between the cerebral hemispheres is important for healthy brain function. The importance of this communication can be seen with the processing of sensory information, which is typically received first in one hemisphere and then must be shared with the other hemisphere. When you type on your keyboard, for example, information about the feel of the keys is sent up from your right hand to the primary somatosensory cortex on the left side of your brain. That information must then be shared with the right side of your brain as well. That's where the corpus callosum comes into play. It carries information received in one hemisphere over to the other, and in general allows for communication between the two hemispheres.
One of the phenomena involving the corpus callosum is the behavior of sufferers of severe seizures, and they are sometimes given a split brain operation to stop the seizures. The outcome is that the two hemispheres no longer communicate in the same manner that they did pre-surgery. Here is a clip of a video about a patient who had a split brain operation and the behavioral outcomes.
Okay. But when Joe is given the same task, his two hands operate as if controlled by two separate brains. What's happening is that each half of Joe's brain is given a separate instruction. He's asked to fix his eyes on the cross in the center of the screen. Anything flashed to the right of the cross goes only to his left hemisphere. Things to the left go to his right hemisphere. Because the two don't communicate, each hand does only what its half of the brain sees.
Wow, look at that. It's really like two different people doing the same.
That's right.
Same
That's
task.
That's the idea. Okay, Joe, I want you to keep your hands out in front
In
of
an experiment that's now a classic in brain research, Mike Azaniga over 30 years ago used a similar setup to find out if the two halves of the brain are specialized to do different things.
Ship.
Joe is being flashed a word only to one half of his brain. Words flashed to the right
Storm.
are seen only by his left brain, and Joe can report seeing those words just fine.
Piano. Good.
But when a word is flashed to his right brain,
Didn't see that. Okay. Joe, I'm going to ask you
but now watch what happens.
to draw that with your left hand.
You get me lost.
Why don't you try drawing another picture of it over here if that will help you.
Oh, phone.
Oh, okay.
Sure.
It's almost as though somebody has given him a secret communication.
That's
and
right.
now he knows that it's a telephone. But up until then, he was blind to it.
Exactly.
The field that I currently work in is user experience research. I conduct research for UX and UI features and prototypes to see how users interact with digital platforms through various forms of studies in order to gather data which provides insights for digital designers and developers. In this field, it is thought that to have important text like navigation on the left side of the screen, because that is where it is the traditional place where English readers start, left to right. Here's a clip to explain the design best practice currently suggested by industry leaders, the Nielsen-Norman Group. Here is a quick clip that describes this design guideline.
Laptop or desktop monitor. Second, stick with familiar locations when placing navigation menus. On large screens, this means the top or left edge. When you put navigation menus in unusual places, like the right edge of a screen, or underneath a header so large that the menu is actually pushed down to the middle of the screen, people are much less likely to notice your menu. The third tip.
In conclusion, I think that in light of what neuroscience has discovered about the left and right brain function related to sight, it may be more effective to place the important text, like navigation, on the right side of the screen. But guess where most ads are traditionally placed in a digital layout? You guessed it, on the right side of the screen. In conclusion, learning how the corpus callosum operates can translate into other fields outside of neuroscience, like design. Here is a list of my references for this presentation. I hope you enjoyed it.